Unit 3 is a big data unit. This is a very important unit. Make sure we understand this unit. It's all about how derivatives can tell us whether things are going up, going down, concave up, or accelerating, concave down, decelerating. It's all about sign analysis. When is this function decreasing, concave up? Well, we can figure out when it's decreasing based on the signs of f prime. If f prime is negative, it's decreasing. Concave up, we say, well, if f prime values are decreasing, that means f double prime values are negative, or sorry, going the opposite way. If f prime values are going up, that means f double prime is positive, will be concave up. So we got to figure out when is f prime negative, f double prime positive. How we do that is we find when signs could change. We will find when signs are zero. So to figure out if something's positive or negative, find zeros. Because in between zeros, all of our values are positives or negatives. We know that for a certain. So I'm going to start by taking the derivative. I get x squared minus 6x plus 5. I will find the zeros of this. I could factor this to be x minus 5, x minus 1. Oops. And I will get 1 and 5. What I'm going to do with that 1 and 5 is plop it down on a number line for f prime, 1 and 5. Now, since these are our zeros and I've exhausted all my zeros, I'm also going to figure out when things are undefined. Don't neglect that because we can change signs of something that's undefined. I know we don't have something that's undefined because we do not have a denominator, but be careful. If you do have a denominator, set that equal to 0 as well. But since I've exhausted all my zeros, I know these are either positive or negative values consistently. One or the other, it can't change sign because if it changed signs, we'd pop through another 0. All we need to do is test some points. Like if I plugged in 6, well, I plug in 6, positive, positive, I got a positive here. If I plug in 3, that'll be a negative times a positive. So that'd be a negative. I know all my signs are going to be negative. If I plug in 0, it'd be a negative times a negative. That's a positive. So I know we are decreasing between 1 and 5. F is going to be going up because f prime is positive. F is going down. F is decreasing because f prime is negative. F is increasing after 5 because f prime is positive. We will go one step further to analyze the concavity by looking at a second derivative. My second derivative is 2x minus 6. I'll exhaust its zeros or see when it could change signs. I find that it's just at 3. I'll throw down another number line. I'll make sure it's lined up with my first one. I see 3 is in between 1 and 5. If I plug in something a little bit greater than 3, I get positives. 4 times 2 is 8 minus 6. That's a positive. Plug in something like 0, I get negative 6, negative. Now the signs of f double prime tell me if f prime is increasing or decreasing. F prime's decreasing, f prime's increasing. But what that tells me is whether f is concave up or concave down. Here, f would be concave down. Here, f is concave up. When are we decreasing and concave up? Decreasing and concave up is this interval right here, 3 to 5. This is, in a nutshell, all of function analysis. If we could do this, we're good. But not all questions will look like this with function analysis. Sometimes we need to understand, okay, this is the graph of f. What does it mean if f prime is positive and f double prime is positive? Well, it means when is f going up and when is f concave up. I would not look at slopes. I would literally just look at the graph. Here, I'm going up and concave up. -1 to 0. So careful, what are you given? I'm given f of x. I can just kind of translate this and just look. More questions. You know, here's f of x, order from positive, negative to 0. Well, I see f of 2 is 0. I see f prime of 2 is the tangent slope. Okay, that's positive. How do I find f double prime of 2? Well, I notice that this function looks like it's concave down. So f is concave down. That means f double prime must be negative. So 0, positive, negative. If I were to order this from least to greatest, you would say f double prime is the least value that is less than f of 2, which is less than f prime of 2. Another different type of function analysis question. A lot of times you will be given graphs of f prime. And we'll ask to analyze f, like what is going on in the graph of f if this is f prime? What I advise you to do, just like we did with the first function, is analyze the signs of f prime. Now we realize if this is f prime, these would be negative f prime values below the x-axis. So I'd have negative values until -1. That means f is actually going down until -1. From 1 to 3, My f prime values are above the x-axis, so those are positive. Then from 3 to infinity, they're back to being negative. So f is going down, up, and down. So all of a sudden, I know that f's got a min at x equals -1, and f's got a max at x equals 3, all from just analyzing the signs of the derivative. I could go back to the original situation too, like 1/3 x cubed minus 3x squared plus 5x. I see I have a max at 1, a min at 5, a point of inflection at 3. Now let's look at f double prime. To understand the signs of f double prime, you could look at the slopes of f prime, or if f prime is increasing or decreasing. Here, the slopes of f prime are positive, or f prime is increasing. They are positive until, I'll use red here, 1. Then the slopes of f prime are negative, or f prime is decreasing. Now, if f double prime is positive, that tells me f is concave up, f is concave down. So just from the analysis of f prime, I realize f's got a min, a max, and a point of inflection. You could actually probably sketch a nice little example of what f would look like. Decreasing concave up would be like that. Increasing concave up would look like this. Increasing concave down, look like that. Decreasing concave down, look like that. So we'd have some sort of cubic function. Well, that makes sense. This is a squared function, so we know that a cubed derivative would be a square, but this would be the more specific shape with the more specific locations. We know this is at -1, this point of inflection is at 1, this max is at 3. The locations we don't care about right now. We will in the future. But be careful. Sometimes students think that points of inflection or maxes and mins are when, a derivative equals 0. So they say, what are the points of inflection for f of x? If f double prime is x and x minus 1 squared and x minus 3. And they say, oh, 0, 1, and 3. Nope. You're close, but you're wrong. Because if you analyze the signs, you realize that not all zeros do we change sign. I know for a fact that at 1, we are not going to change sign. Why? Because we have x minus 1 squared. Now watch, you can do a little sign test analysis. Let's plug in 4, positive, 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 or get positive. Plug in 2. That'll be a negative. That'll be a positive, positive, so that's a negative. Let's plug in 0.5. That's a negative. This will be a positive because I'm squaring. This will be a positive. So this is a negative. Plug in -1, negative, positive, negative, that's a positive. All of a sudden, the points of inflection are just at 0 and at 3. 1 is not a point of inflection because it doesn't change sign. We would be going concave down. We'd probably flatten out so much that we'd have a point where we don't have any concavity, and then we'd do concave down. This is similar to like x to the 4th. Y equals x to the 4th. Its second derivative is 12x squared. It has a 0 at 0, but it doesn't change sign at 0. It's positive and positive, and we know x to the 4th just like flattens out a little bit more than x squared. It has one point where we don't have concavity. Okay, so please be careful. Same thing with this. How many relative extreme points of inflection does f have given the graph? A lot of people were like, okay, well, 1, 2 points of inflection. That's when f double prime equals 0. And they're like 2 points of inflection. And then 2 sign changes of f prime. So 2 maxes and mins. And you're wrong. This is not a point of inflection. Because if you looked at f double prime, you'd be going negative to a 0, yes, but then you're going back to a negative. You do not change sign. This is not a point of inflection. Okay? We would know that this would be a location of a max because f prime would be changing signs from positives to negatives here. And then this would be a location of a min. It's not like that location on f. If this is like x equals 3, f of 3 would be a max on the graph of f. f of, whatever this is, 5 would be a location of a min on f. Okay, so this is indicating by looking at the signs of f prime what f is going to look like. So please be careful. Don't just assume zeros or points of inflection or maxes and mins. Make sure signs change. All right, that was unit 3.